Okay, section 3.5 is on solving systems of equations in 3 variables. Okay, before we get to actually solving these, we're going to first of all look at what a systems of equation looks like in 3 variables, or an equation in 3 variables looks like. So let's look, a problem like number 1 is going to give you a multiple choice situation and ask which one is a linear equation in 3 variables. Your options will look like this. Okay, so there's what your options will look like. So first of all, it needs to be a linear equation, which means the variables will not be in the denominator. So it won't be that one. Also, it needs to have 3 variables. This one has 1 variable, and this one has 2 variables. This is the only one that'll have x, y, and z, so 3 different variables in its equation. Now, number 2 is going to ask, what does a systems of equation answer in 3 variables look like? Well, if you'll remember, if you have 2 different variables, your answer will come like this, as an ordered pair. Well, just like that, if it's an ordered triple, it'll just look just the same as an ordered pair, except it will have the 3 different variables inside those parentheses like that. Now, I'm going to work a couple of these problems for you. I'm going to start off by working number 4, and then I'm going to work number 7. Okay, 3, 4, 5, 6, and 7 are all very similar. They follow the same steps, and since they each take so much time, I'm just going to work a couple of them. If you have any questions, you can email me always. Okay, let's look at number 4. It's going to say solve the systems of equations. It'll look like this. There's the first equation. There's the second equation. And there's the third equation. So what we're going to do is we're actually going to find out what x, y, and z all equal by using the elimination method. So what we want to be able to do is add 2 equations together, any 2 equations, and eliminate or cancel out one of the variables. So the easiest thing to do is to find an equation that just has an x or a y or a z, because we're going to have to multiply this by something that will knock out these other 2. So I'm going to start with this x equation right here. If I want to add it to this equation right above it and knock out this x, I will need this x to be a -4. So that's why I like to choose equations that have coefficients of 1 in front of one of the variables, because I can multiply this equation by whatever I need it to be to turn this x into whatever it needs to be to knock this out. So let's bring this one down. So in order to knock out this 4x, I'm going to need to multiply this last equation right here by -4. Because that'll make that a -4x. So I'll multiply this side by -4. And this side by -4, right? Because if I multiply one side by -4, I have to multiply the other side by -4. So when I multiply all this by -4, I will get -4x plus 12y minus 8z equals, multiply this side by -4 to get 52. So I multiplied this one by -4 so that I can add it to this one. So let's just bring this one down to where we are. So 4x plus 2y minus 3z equals 15. Now look what happens when I add these 2 equations together. The x's knock each other out. 12y and 2y gives me 14y. Negative 8z and negative 3z gives me negative 11z. And 52 and 15 gives me 67. So we are going to keep this one where we can come back to it easily. Now, I want to do the same thing again. If I knocked out the x's once, I need to use two different equations, not these two, but any other combination of equations, and knock the x's out again. So again, I'm going to choose this equation, and I want to knock out the 5x this time. So just like I did here, I'm going to do it with this equation again, but in this time, since I need to knock out a 5, I'm going to multiply this one by negative 5. So I'll have negative 5, x minus 3y plus 2z equals negative 13 times negative 5. So again, I'm doing the same thing. I just need to I'm going to distribute this negative 5 to get negative 5x plus 15y minus 10z equals 65. So now that it has a negative 5x, I can add it to this equation that has the positive 5x. So that's what I'll do. I'll just bring this positive 5x equation down here. And then add these together. So once I add these together, you'll notice, here's the whole reason we did that. I'm going to eliminate these x's. Those cancel. 15y minus y is 14y. Negative 10z plus 1z is negative 9z. And 65 and 0 is 65. So now, look at these two starred equations that we have left. They both, I'm going to write them one on top of another. 14y minus 11z equals 67. And then 14y minus 9z equals 65. So what you'll notice is we have now created two equations that only have y's and z's because we have eliminated both of their x's. So now I need to eliminate another variable so that I get down to just one variable that I can solve for. Well, since these are both 14y, I can just multiply either one of them by that negative 1. Because if I multiply this by negative 1, it'll make it a negative 14y that I can add to the positive 14y. So let's distribute this negative 1 here. So I'll have negative 1 times 14y gives me negative 14y. Negative 1 times negative 11z gives me positive 11z equals negative 1 times 67 gives me negative 67. So now look what happens when you add these two together. The y's cancel out. I'll have negative 9z plus 11z, which is 2z, equals 65, and negative 67 is negative 2. So now look what you have created. You eliminated the x's, then you eliminated the y's. So now all you have left to solve for is z. So to get z by itself, I just need to divide both of those sides by 2 to get z equals negative 1. So now I know the z answer is negative 1. So you take this and go back to either one of these starred equations. These starred equations right there both have a z, which now we know is negative 1, and just a y. So I don't have an x. So if I can plug this negative 1, I'll use this top one. I'll plug it in this z spot. So when I do that, I'll have 14y. Now, I'm going to have minus 11. Now I know that z is negative 1. I'll put my negative 1 there, equals 67. Well, negative 11 times negative 1 gives me positive 11. So now I have 14y plus 11 equals 67. And then solve for y. So subtract the 11. So 14y equals 56, and then divide by 14. So y equals 56 over 14, which is 4. So there's your y answer. So now I know y and z, which means I can take both of those up to the very top and plug in what I know for y and what I know for z. And I can actually use any of these right here. So I don't know x, so I'll still have 5x minus, I do know what y is. Remember, you found out down here that y is 4. Plus, then I need to add the z. Well, z is, I have found out here, is negative 1 equals, that equation tells me that that should equal 0. So now look what you have. You've got your last equation to solve. This one will give you what the x is. So I have 5x minus 4 plus a negative 1 is the same thing as just saying minus 1 equals 0. Combine those like terms. So 5x minus 5 equals 0, and then solve it for x. So add 5. So 5x equals 5, and then divide by 5 to get x equals 1. So now you know x is 1, y was 4, and z was negative 1. Okay, so I'm not going to work every single one. I'm going to jump to number 7. Same kind of problem. Solving another systems of equations. This one will have, the first equation is 5r minus s plus t. Actually, let's work number 6, because number 7 is almost exactly like the one I just worked. So let's work number 6. It's a little different. You have 6x plus 3y plus z equals negative 6. X minus 3y plus 2z equals 24, and then 17x minus 2y plus 3z equals 26. So again, 6x plus 3y plus z equals negative 6. X minus 3y plus 2z equals 24, and 17x minus 2y plus 3z equals 26. So again, I am looking for any variable that has a coefficient of 1, because it's easy to turn those 1s into whatever we need them to be to knock out other variables. So if I'm looking at this first equation, look, here's a 1z. So I'm going to use this one to knock out the 2z, and then use it again to knock out the 3z. So let's use it to knock out the 2z first. If I'm going to knock out 2z, I would need this z to be negative 2. So that's exactly what I need to multiply this equation by, is that negative 2. So negative 2 times 6x plus 3y plus z equals negative 6 times negative 2. So let's distribute this negative 2. So that'll give me negative 12x. Negative 2 times 3y is negative 6y. Negative 2 times z is negative 2z equals negative 6 times negative 2 is positive 12. So since that's a negative 2z now, I'm going to add it to the equation that has the positive 2z. So let's just bring down this equation, which will be x minus 3y plus 2z equals 24. And add these two equations together. So negative 12x plus 1x is negative 11x. Negative 6y and negative 3y is negative 9y. There goes your z, so they cancel. Equals 12 and 24 is 36. So again, star that one. We're going to use it later. Now, I use this z to knock out the 2z. Now I'm going to use this z again to knock out the 3z, which means this time I'm going to multiply the top one by negative 3. So I'll have negative 3 times 6x plus 3y plus z equals negative 6 times negative 3. So let's multiply this. So negative 3 times 6x is negative 18x. Negative 3 times positive 3y is negative 9y. Negative 3 times z is negative 3z equals 18. So there's this one. Since it's a negative 3z, I'm going to add it to this bottom one to knock out my z's. So let's see. I'll just bring this down. 17x minus 2y plus 3z equals 26. So let's add these together and see what we get. Negative 18x plus 17x is negative 1x. Negative 9y and negative 2y is negative 11y. Your z's are eliminated, equals 44. So there's your other starred one. So now let's bring down your two starred equations and write one on top of the other. So I have negative 11x minus 9y equals 36. Add that to negative 1x minus 11y equals 44. So now we have got to eliminate another variable. So when I'm looking at these x's right here, what eliminates a negative 11x? A positive 11x. So let's see what happens. If I need this to be positive 11, I'll need to multiply it by negative 11, right? Because if I multiply it by negative 11, it'll change this x to a positive 11 that'll eliminate that one. So let's distribute this negative 11. So I have 11x. Negative 11 times negative 11 gives me positive 121y equals 44 times negative 11. Hang on, let me get my calculator. Gives me negative 484. So now, don't think about that. I'm adding this one and this one together to eliminate my x's. So let's see what happens. The x's eliminate. Negative 9y plus 121 gives me 112y equals 36 minus 484, which gives me negative 448. So now I just need to divide both sides by 112 to solve for y. So when I divide this negative 448 divided by 112, it gives me negative 4. So y equals negative 4. That's the hardest part, is coming up with the first unknown. Because now, remember, you take this negative 4 and you go back to either one of the starred equations, because they're the ones that are going to have just a y and one other variable. So if I take it to this top one and plug the negative 4 in for that y, I will have negative 11x minus 9 times negative 4 equals 36. Multiply there, so negative 11x plus 36 equals 36. Subtract 36 from both sides. So negative 11x equals 0, and when you divide by negative 11, you still get x equals 0. So now I know x and y. I just need to solve for z. So again, I take the x being 0, put it there. I know the y is negative 4, and I'll put it there in this top equation to solve what I have left. So I have 6, the x is 0, so I'll plug in a 0, plus 3 times, now I know y is negative 4, plus z equals negative 6. Well, 6 times 0 is nothing. 3 times negative 4 is negative 12, plus z equals negative 6. And then solve for that z. So all I need to do to solve for z, sorry, I lost my train of thought. All I need to do to solve for z is to add the 12 to both sides. So now z equals negative 6 plus 12, which is 6. So there's your z and your y and your x.